Factoring polynomials. That's what we're going to do right now. Factoring polynomials is a short extension of what you learned about finding the greatest common factor of monomials. And it's one step in the direction towards a whole smorgasbord of factoring. So let's start with an example like this. 2x to the third minus 5x. Factoring essentially means we're looking to do the reverse of the distributive property. We're looking for the greatest common factor of all of the terms in the polynomial. If we look at this polynomial, we have 2x to the third, and we have negative 5x. With the numbers 2 and 5, they don't have a greatest common factor other than 1. So now we consider the variables, x to the third and x. The greatest common factor of those two terms is x. So I put my x out here, and then I've got a set of parentheses. And if I take one x out of x to the third, well, there are 3 x's in there. I just pulled one out as a factor. Now I'm left with 2x squared. In the second term with negative 5x, I just factored out this x. So if I have negative 5 times x, but I pull out that x, I'm just left with negative 5. The great thing about factoring polynomials is it's really easy to check your work. We're just going to reapply the distributive property to see if it works out. So I take my x, multiply it by 2x squared. Well, 2 times x squared is 2x to the third. That one checks out. X times negative 5, that's negative 5x. So x times, parentheses, 2x squared minus 5 is the factored form of this original polynomial. Excellent. Let's do another one. In this next one, we have a polynomial with 3 terms. We've got 12n to the fifth minus 8n cubed plus 20n. Let's consider the coefficients first, the numerical portions. 12, 8, 20. What number goes into each of those evenly? Well, 4 does. Each of these numbers is divisible by 4. So my greatest common factor will be 4, and then I look at the greatest common factor of the variable portions. N to the fifth, n to the third, and n. The biggest factor of n that goes into all 3 of these terms is going to be this smallest power of n, which is just n to the first, or n. Now with our set of parentheses, well, 12n to the fifth, 4 times what is 12? 3. N times what is n to the fifth? Well, that would be n to the fourth, because I started with n to the fifth and I pulled out one of the n's and I'm left with n to the fourth. For negative 8, well, if I divide that by 4, I'm left with negative 2. I pulled out one of the n's, leaving me with 2 left here. So an n squared. And then the last term, 20n, I factored out 4n. Remember, factor just means numbers that are being multiplied together. So 4n and a factor of 5, because 4n times 5 would be 20n. Once again, we can distribute to see if this works. We take the 4n, multiply it by each of these terms, check it out, see if we get back to where we started. 4 times 3 is 12, n times n to the fourth is n to the fifth, 4 times negative 2 is negative 8, and I've got the n times n squared, which is n to the third, and 4n times 5 is 20n. Hey, that worked out really well also. Let's take a look at another example, and maybe if you follow along carefully, I'll do even a bonus example at the end. We'll see how it goes. All right, here we go. Negative 14a to the third minus 7a squared. Ugh, a negative, yuck. I don't want to deal with the negatives here. So the first thing I'm going to do is pull out the negative. Now I can take a look at considering if I pull out the negative, I'd really have this expression, flipping the signs of everything in those parentheses. Now it might be a little bit easier. I don't have to think about the negative anymore. I've already taken care of it. So I've got my negative. What is the greatest common factor of 14 and 7? It's 7. What's the greatest common factor of a to the third and a squared? The biggest number of a's we could fit into 3 a's and 2 a's is a squared. So I'm going to factor out the a squared. Now what's left inside the set of parentheses? 7 goes into 14 twice. I started with a to the third. I took out 2 of those a's, leaving me with a single a left. And now, well, let's see, I took the 7 out of 7. 7 divided by 7, that's just 1. A squared divided by a squared, that's 1 also. So this is just 1. It's negative 7a squared times 2a plus 1. Once again, we're going to use a distributive property just to see what happens. Great way to check our work, make sure we've done this properly. Negative 7a squared times 2a. Negative 7 times 2 is negative 14. A squared times a is a to the third. Negative 7a squared times 1 is just negative 7a squared. That checks out. So negative 7a squared times parentheses 2a plus 1 is the factored form of this original polynomial. All right. You guys are following along really well, so let's do one more. Let's do 15m squared plus 7. What is the greatest common factor of 15 and 7? Well, 1 is the only number we can divide evenly into those. And there's no part of the term with 7 that has an m in it. So it looks like the greatest common factor is just 1, meaning this polynomial can't be factored anymore. We're done. That's it. When the greatest common factor of all the terms is just 1, you're done factoring. Move on to the next problem. That's how to factor the greatest common factor out of a polynomial.